You've probably watched it happen in your rearview mirror. A semi-truck flies past you on the interstate, 80,000 pounds of cargo behind it, an engine block under that hood the size of a refrigerator, and you assume that thing is on its last legs, halfway to the junkyard. But that engine has probably already driven the equivalent of going to the moon and halfway back, and it's nowhere near done. Some of them have been running for 3 decades on the original block, the original crankshaft, the original cylinder bores. Meanwhile, your car, sitting in your driveway with a fraction of the workload, will be ready for a new engine somewhere between 150,000 and 250,000 miles. Why does a 15-liter Cummins outlast a 2-liter Honda by a factor of 5, sometimes 10? The obvious answer is diesels are built tougher. That's not wrong. It's just incomplete in a way that hides something genuinely strange about how engines actually wear out. Something connected to the food in your fridge, the package on your porch, and the bus that took you to school. The full reason has 4 parts. Most people only ever hear the first one, but let's start with what almost everyone gets wrong. The first thing every mechanic will tell you is that truck engines are built like tanks. And it's true. Open one up and you're looking at gray cast iron everywhere. Block, head, often the oil pan. The crankshaft is forged steel, riding on 7 main bearings instead 4 or 5 in a typical car engine. The cylinder liners aren't part of the block at all. They're separate sleeves pressed into the casting and designed from day one to be pulled out and replaced when they wear. Cummins X15 by itself weighs more than an entire Honda Civic. None of this is decoration. The car, a truck engine, is built to be opened up, rebuilt, and put back to work 2 or 3 times. It's not really a vehicle component. It's an industrial asset that happens to live inside a vehicle. But here's where the explanation falls apart. If brute construction were the answer, you could just bolt a cast iron block into a car, give it a forged crankshaft, drop in replaceable liners, and watch it run forever. You can't. Engineers have tried. They still die early. The metal is a clue, not the answer. Your car engine and a truck engine are made of essentially the same elements, burning the same chemistry, breathing the same air. So whatever is making one die at 200,000 miles and the other live to 1,000,000, it has to be something happening inside the engine. Every time it runs, that wears one out 4 or 5 times faster than the other. And that difference has almost nothing to do with how well the engines are built. It has almost everything to do with what they're being asked to do every single second they're running. Because what the math actually says is that your car engine isn't dying, it's being killed. But the real reason goes deeper than any of this. Pop the hood of a Honda Civic Type R. Inside is a 2.0-liter 4-cylinder engine producing roughly 315 horsepower. That's 158 horsepower per liter of displacement. Now, look at the Cummins X15 in a Class 8 Freightliner. 15 liters producing 400 to 500 horsepower in most configurations, peaking at 605. That's somewhere near 27 to 40 horsepower per liter. The car engine is generating roughly 4 times more horsepower per liter than the truck engine. Per pound of metal, your car engine is being asked to do 4 times more violence than the truck engine is ever asked to do. Engineers call this specific output, and inside the engine, it translates to cylinder pressure, the force pushing down on the piston during combustion. A heavy-duty truck diesel runs at high cylinder pressure, but it does it inside a cylinder the size of a coffee can with a piston the weight of a small dumbbell, riding on bearings the size of donuts. There's mass everywhere absorbing the load. A small turbocharged car engine has to generate similar peak pressure inside a cylinder the size of a soda can, with components a fraction of the weight, spinning thousands of RPM higher. The same combustion event is hitting much smaller, lighter, faster moving parts. Engineers call it the truck engine is deliberately understressed. Every component is sized to handle far more than it'll ever actually be asked to do. The car engine doesn't have that luxury. It has to be small, light, and cheap. So it's designed to run up against its physical limit. And this connects to something running in your kitchen right now, but we'll get to that. Because if understressing were the only factor, you could buy an enormous lazy car engine and put 700,000 miles on it. People have tried. The old big block V8s of the 1970s were practically idling at highway speeds, and they still didn't reliably hit 1,000,000 miles. So even an understressed engine doesn't get there unless something else is also true about how it's being used. The single most damaging thing that ever happens to your car engine is starting it. Not driving it, starting it. Cold start research from Argonne National Library and decades of studies have all converged on the same conclusion. The first 30 seconds after a cold start, before the oil has reached operating pressure, is when most of your engine's lifetime wear happens. Multiple studies estimate a single cold start can produce wear equivalent to several hundred miles of warm running. In freezing conditions, it gets worse. Now, think about how you actually use your car. Drive to work, stop. Drive to lunch, stop. Drive home. Each of those is a cold start, or close to one. The average passenger car endures around 1,000 to 1,500 cold starts per year. A long-haul truck might do a couple hundred. The truck driver pulls out of the terminal Monday morning, and that engine doesn't shut off again until Friday night. There's something else hiding in there too. The car on the highway is cruising at 2,000 to 3,000 RPM. A heavy-duty truck cruises at 1,400 to 1,600, a third lower. Lower RPM means fewer combustion events, fewer ring strokes against the cylinder wall, less wear per mile. Multiply that across 1,000,000 miles, and the gap becomes staggering. Your car engine isn't dying because it's badly built, it's dying because of how you use it. This is also where the history gets interesting. Before the interstate highway system was built, starting in 1956, long-haul trucking barely existed. A pre-World War II truck engine that hit 100,000 miles was considered a miracle. Mechanics literally drained the oil out of engines at night, stored it warm indoors, and poured it back in before morning. But the interstate created routes 1,000 miles long, and suddenly fleets needed engines that could run continuously for years. That demand drove an industrial reliability metric called B10 life, the mileage at which 10% of a fleet has needed an overhaul. The Detroit Diesel Series 60, introduced in 1987, was the first fully electronic heavy-duty diesel, and surviving examples have been documented past 1.5 million miles on the original block. Therefore, the 1,000,000-mile engine isn't really an engine. It's the result of a 70-year argument about how reliability should be designed. And once you see that argument, you start seeing it in places you didn't expect. The same engineering philosophy that put 1,000,000 miles on that semi-truck is touching your day in ways you've never noticed. Start with the bus that took you to school was almost certainly a diesel, designed for service, lives of 15 to 20 years, and 250,000 to 500,000 miles. A million-mile rated engine carrying a child to second grade. Then the garbage truck that comes down your street every week, diesel. The locomotive that pulled the freight train heading to your local store. Modern EMD and GE locomotive diesels routinely run the equivalent of 3 million miles before a major overhaul. The architecture is the same family of engineering, just scaled up. The cargo ship that brought your phone across the Pacific runs a marine diesel that'll be in service for 30 to 40 years. The hospital generator that kicked on last time your neighborhood lost power. The data center backup keeping your bank account online during a storm. The supermarket's emergency generator that kept your frozen food frozen. The construction crane downtown. The mining truck digging up the copper inside your home's wiring. Even the diesel-electric submarines protecting coastlines run engines from this same lineage. Every Amazon package on your porch rode behind one. Every gallon of milk in your fridge, every prescription at your local pharmacy. You've been surrounded by this single engineering decision your entire life and never questioned it. So, here's where you actually land. You looked at that semi flying past you on the interstate and you thought, big truck. But what you were actually looking at was a deliberately understressed engine running at a fraction of its peak capability, a cast iron block designed to be opened and rebuilt 3 times, a cylinder pressure margin built in by engineers who decided durability mattered more than weight, a duty cycle that almost never includes a cold start, a 70-year competitive argument between Cummins, Detroit Diesel, and Caterpillar over how long an engine should physically be able to live, and an entire economy built on the assumption that one engine can move freight for 1 million miles without quitting. You're not looking at a vehicle. You're looking at the machine that quietly built modern life. And if you think a 1 million mile engine is strange, wait until you find out why almost every new diesel truck on the road today has an emissions system that fails at exactly 100,000 miles and what that's quietly doing to the 1 million mile engine underneath it.